Hi guys, welcome to Learning Electronics Repair. A little bit of amplifier repair today. So I have two amplifiers here. If you're a regular viewer of the channel, you may recognise this one. So MF-1200 Mosfet professional power amplifier. This is quite an old amplifier. And this has two short circuit output transistors, or Mosfets. These are 2SJ and 2SK. TO3, so like the metal can type ones, kind of like a funny shape, yeah, like that shaped, okay. And the MOSFETs are obsolete and they're expensive, yeah, you're looking like $40 each. And each amplifier had more than one pair, but there was only one pair shorted. So the problem with this was getting spare parts. So it's sat here for quite a while now, and then the owner brought me this one in and he said, Rich, I've got another one of these amplifiers, this is also faulty. He says use this one for parts to get this one working, and then he says whatever's left you can keep, okay, plus you'll pay me my time to actually do the job as well. So that's what I'm going to do. Now I don't actually know what's wrong with this one, so if I get really lucky, this is going to be maybe one blown channel. I can't remember exactly how this thing was inside now. Can I just swap one channel or whatever? Maybe something else wrong with it. So let's power this one up and let's see what it does, and then let's figure out the best way to get one good working one out of these two, if I can. I'll just mark them. So this one actually had a broken switch as well. This has a good switch, so that solves at least one problem. So this is the one that had the faulty MOSFETs in. Let's get the top back off and see how this thing was actually constructed. Okay, so now I can remind myself. I have all the bolts and fittings here. This does have two channels, okay. These are the transistors I was talking about. Okay, so J56 or 2SJ56 and 2SK176. These are quite unique. These are nothing like modern MOSFETs. First of all, they have a very low gate threshold voltage of about 0.2 of a volt. Yeah, very low. These were made, if you like, as audio power transistors, and they behave quite differently to just about anything else. So you can't just find a modern replacement. There are other similar ones that were made at the same time, but they're also obsolete, and they are as hard to find as these are. Okay, so that's what we have. So this is the blown channel. Okay, it's marked J and K. I think the ones which are still in there are the short circuit ones. I think the ones in the bag are all the good ones. I'd have to double check that. That's the good channel. And then we can see quite clearly individual things. So if I get really lucky here, I might have one other good channel in the other amplifier, yeah, and that might just make this job easy. Let's see. Of course, knowing my luck, it probably won't be. When I say this one was the good channel, I don't actually remember if it actually works. It might just be that the other one is the one with the short on, and there was no shorts on this, at least on the output. But we'll see, I guess. And here is the other one. First thing I notice is a little modification here. And I can see the fuse holder's been removed off this one, so it must have been broken at some time. And somebody's made this thing for the fuse. That looks like it might have blown. Let's have a look. No, the fuse seems to be intact, so that's a very good sign, I would say. We could be lucky here. Right. I've just referred to my previous video with one of these. Actually, I didn't watch all of it, just the first part, so I couldn't see any shorts. One channel was working, I had music playing, this channel was working, that one wasn't, and I figured out from the connectors here. So the red one is a positive supply, the blue one is a negative supply, the black one is ground, and the two yellows together go to the speaker, okay, and the other end of the speaker goes to ground. So that's how it's actually connected up. And on the one I looked at previously, these connections went to this channel. So we can just check that actually. So from the speaker out, so these should actually connect to each other. Yeah, they're in parallel. And those I think go to this one. Yeah, and then this is ground. Okay, so it's like the other one. This is the left hand channel, this is the right hand channel. Looking from where I'm sitting, okay. So let's check for shorts on this like I did with the previous one. And the way I actually did it was to check across the bridge rectifiers. So we have two transformers, so we have two power supplies, two bridge rectifiers, two pairs of capacitors. You probably can't easily see, but there's, yeah, down there underneath another pair. And I didn't find any shorts on the other one, even though there were shorts on the amplifier channel. I haven't gone further in to see why that was. There must be something open circuit in the path, I'm guessing. So let's have a look. So this should be ground, actually not to the chassis, but we know that is ground. Okay, do we have a short? No, we see it climbing up, so that's a capacitor charging. This one, again, capacitor charging. So there's no shorts on this channel. The other one is harder to get to because it's kind of like upside down. The connector's all the way down there, but I can check across the bridge rectifier. Do I have a short or anything? No, it's climbing up, so I don't see a short on this one either. I didn't on the previous one, so there is, if there is a short on it, there was something open circuit, which is why I didn't see it. I can just remind myself. That's the beauty of having the other video. Should save me a bit of time. So what I did with the other one, and I'm going to do with this one, is connect the current limiting light bulb. I'm going to use my limiter with two bulbs, 150 watts. It drew quite a bit of power anyway when it was quiescent, but I know how this one should react. So let's try that first and let's see if anything happens on the indicators on the front of the amplifier. Okay, I'm not totally sure which way the power switch is. I said the same with the other one. Okay, let's see. So I have this set to limit. The light bulbs are in series. You can see them there. Let's power it up and what happens? Well, they come on bright and then they go dim. Okay, so that means, again, this thing's not going to blow up. The other one, I could actually hear a relay click when I did that. Let's try again. No, I don't hear anything on this one. That is definitely the off position on, so it's not like a standby thing. Okay, so bright and then goes dim. Right, what we'll do with this one then, we'll connect audio to it, we'll connect some speakers to it. We can take the current limiter out of circuit and let's see if we get any audio coming from it. I have just noticed, by the way, this thing wedged in here. This is, well, it's one of those, so you can see, let me just show you. Under here, there's like a plastic insulator, which is stopping the metalwork of the heatsink from touching the chassis of the amplifier, and that's one of those. Interesting. Okay, well, we know about it at least. Okay, because I've attached my speakers, that effectively is another current path from the output of the amplifier to ground. So I have the current limiter on again. Let's just see. And the same thing, bright then going dim, so I'll switch that out of circuit. I don't hear the relays click on this one, which is, tells me something at least that isn't the same with the other one, okay? So we'll just power it up. I heard the relay that time. No lights lit up. A bit of Northern Soul, of course, now. What happens? Wow, same as the other one, I have one channel working, and in this case it is the one to the left of me. So one of the amplifiers works and one of the other amplifiers works, so this looks like it's going to be fairly simple so far. And interestingly, it's the one at the front again that's working and the one at the back that isn't. Is that just chance? I mean, you know, if one channel is working and one isn't, well, the chances are 50-50, so it's not, you know, beyond the possibility of chance. But it is interesting that on both of these amplifiers I had good amplifier on the front and a bad one on the back. Okay, so let's take the faulty one out. Let's put the other good channel in, and we should have hopefully one good working amplifier here. And of course I will just check to make sure the capacitors have discharged. Well, this was the good channel. Yeah, it's reading practically nothing now. Okay, it is reading, so I have a good connection. Yeah, so capacitors have discharged. I can't easily test on the other one, but I can again test by measuring across the bridge rectifier, which should be across both capacitors in series basically. Yeah, and it reads a voltage, so obviously there was some charge in both sets, so both power supplies I'd say are working. This is the bad channel, so let's have a look to see if we can see any problems with this. If I can see some problem with the channel itself, I'm happy to put both of the working channels back into the same amplifier on the basis that there is not another problem with like the input circuitry or something. Okay, so there's no shorts on this. Clearly we could see that there's no short because the light bulb is going dim, the thing powers up. But on the previous ones of these I had problems with the Mosfet, and these Mosfets seem to fail in a different way to modern ones. And what appears to be the case is the gate effectively fails. If we look at the good channel, so gate source, on these the metal can is a source, by the way, this says drain here. Okay, so that reads open, open, and you'd expect that to mean basically the gate should be open. Yeah, 4 of these are N-type and 4 are P-type, but we'll just stay with the same polarity. They all read open. Okay, if we compare that with the bad one, so gate source 380 ohms. Okay, the other one read open, 380 ohms. $311 ohms, so different. 39 ohms, very different. So you can see that these have a problem in the gate circuit. Okay, 1.6K, they're all measuring different, you can see that. It may be that they're not all faulty. That one just went to open, then red again. The only way to say would be to take them all out because they are wired in parallel. So I did that with the other amplifier and I found I had some good ones. But what we do know is that this channel is okay and we have another channel which is okay. So let's put these both back into the amplifier and see if it works now. What do we got? Okay guys, so that's working on both channels. So we have one good working amplifier. You know, I always use this Northern Soul track. One of the main reasons is that there seems to be no issue with copyright on it, yeah? Okay, so we have one good working amplifier. I'll ask the customer to give that a good test. Now let's see what else we need to do with this. So the fan was spinning, so that's okay. We have a problem with this fuse holder. I decided to use this case because it's in the better condition of the two. Other than the fuse holder, I think everything else is basically okay with this one. So let's see if we can take the fuse holder off the other one because at least that's in one piece. This one at least has the good on-off switch. And let's just repair that. Here we see the fuse holder on the other amplifier, But I had a look at my stash. I have one here which is physically the same size. So as long as I can find a nut for this, hopefully I can, I'll actually fit this one onto the other amplifier and I'll leave this one in here. I'll just check to make sure they are actually the same size fuses. They are, so this one doesn't have a fuse in. I think they're actually identical, these. I think this will actually screw into there. Let's see. Yeah. No, not quite, but they take the same size fuse. We can just check that. I'll take the fuse from this one. Yeah. Yeah, so the same size fuse. Let's just now check to make sure this is the correct current. I mean, there's no real reason why it shouldn't be, but you know, things happen, especially on this channel. Yeah. So what do we have here? 250 volt F10A, 10 amp, okay? And it says 10 amp up by the fuse holder on the back of the amplifier. So underneath here we have a fuse holder. This is, yeah, it's like a PCB mounted one that they've used, soldered the wires on, and then they've obviously put the heat shrink on just to protect it and left enough space at the top to actually change the fuse. So for a bodge job, not so bad, to be quite honest. Of course we can do better. We can fit the other fuse holder on here. I find a lot of equipment here that has these kind of bodge jobs. I mean, I'm sure you guys have noticed that as well, actually. I don't know where they're doing them, but somewhere on the island they are. Maybe you would all like to say something about that. So, handy. What fuse did they put in? We'll have a look in a minute. Let's change this one. Okay, so I managed to find the nut for it. I've noted on the other one that the live comes in here and then this goes out to the amplifier. That's normally the way, so that the top end of this isn't live if the fuse is blown when you unscrew that, okay? I mean, electrically it would work just as well the other way around, but for safety, this is how it should be, so we'll fit it like that. Okay guys, so I also noticed one of these is broken, and you can't just unscrew this and put the other one on. At least I couldn't with that one, so maybe I've done it the hard way, but I've just taken the one off the other amplifier, which is here. Okay, it's in better condition anyway, so I'm going to fit this onto this one, and then we have good connectors as well. Okay, so that one's complete now with the good connectors on, the good fuse holder on, the correct fuse in. So this one can go back to the customer. Let's have a look at the one which is now mine. So this amplifier channel is no good. We have two short circuit devices on here, okay. This one appears to have the same problem. Let's see if any of the output devices are actually good on this one. Okay guys, I've got all the output devices off but one. I'm struggling to get this one out. I'm sure I can do, but we can test it anyway while it's in circuit. So these are the K176 or 2SK176. I'm absolutely filthy, you can see, because this was a dirty job. But just before I go and clean up, let's see if these are any good. And if we do have some good ones, we'll see that these are really strange devices, which is why you can't just replace them with something else. Okay, N channel Mosfet, so that's a good one. You see the gate threshold voltage 0.33. I mean, that is like really low. Yeah, you wouldn't find anything else like that, I don't think. So that's a good one. N channel. Try another one. Yep, another good one. This one, yes, good. So that's 3 out of 4. And the other one, which I can't get off the heatsink, but I can test it while it's on there. This may be bad because I had one bad pair on the other faulty channel. Let's see. Yeah, no component detected. Just go again. No component detected. Okay, so that's bad. And then these J56, you can just about see the markings on them, very dirty. These things are very, very sensitive to electrostatic discharge. I will keep them in some foam shortly. That's a bad one. Are these other three good? No, that's also bad. Bad. Now I start to suspect my tester. Yeah. So we'll do this and we'll go back to one of the good ones. This one. Bad. Just check one of these again because it tested good before. Yeah, good. Okay, so I have 3 more good of the 2SK. That's to go with the 3 I already have, so that gives me 6 good ones of those. I have 3 good of the J56. A bit surprising, but all these seem to be bad. Just why not? Let's just double check, but this seems to be the case. Yeah, bad. Okay. These are the ones I previously removed off the other amplifier. It's okay. Let me find a J. They fell out the foam. Yeah, here's a J. Okay. Let's see. Yeah, see, that's a good one, P channel. Okay. So I definitely have 3 of the P channel good and 6 of the N channel. Those are actually quite valuable. If I keep hold of them, if I see another one of these, I'll certainly be able to repair it, I would think. But in itself, I have probably a few $100s there, yeah. And I have this. So the power supply is good. There's a big relay in there, a power resistor, 2 big bridge rectifiers, the 4 capacitors and so on. So I have 2 plus and minus supplies here. A big case, obviously. Some more heatsink and things on here, maybe some voltage regulators. This is the fan speed control, actually. So that's what I have. And obviously the heat sinks and everything that fits in. 2 of these PCBs. So can I do something interesting with this? I mean, the first thing that springs to mind would be, can I make a variable current power supply out of this for testing amplifiers? So I've got a plus and minus supply. I may even be able to arrange it with both transformers that you can put them in series and get even a higher voltage. I don't know what these are. I'd have to look back to the first video or just measure them. But I have 2 of everything here and I have all this space. So not so much variable voltage, but if you get a variable current supply, this would be very useful when repairing or working on things like this. You can also get a plus and minus 15 out of this again with some sort of current protection, though that's not usually where the problem lies. And then use this effectively as a power supply to repair amplifiers. That's one thing I have in mind. You may be able to make a very high voltage, high current, linear, variable voltage and current supply. Or if you wanted to play this easy, you could probably stick some light bulbs in this, yeah, so that you can switch them. So the plus and minus supplies, you can limit them to like 15 watt, 30, 60 and so on. That'd be easier, but maybe not quite so interesting. Okay guys, so I hope you enjoyed that. Obviously I have the cost of repair from the customer as well, because I did what he wanted. I made 1 good one out of 2, took a bit of work, and now this is mine to do whatever I want with, and a very nice bag of transistors to do whatever I want with. Okay, so guys, comment down there. Let me know what you think of that one. Let me know what you would do with this. Very interested to hear. Okay, that will do for today, and I look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now, guys.